This is the notes video for section 6.1, slides 7 through 9. All right, so we're continuing on with indefinite integrals. All right, so here I just want to tell you about the fact that every differentiation rule has an integral rule. So if I were to recall some of the derivative rules, like the derivative with respect to x of the sine of u, right, we should know that the derivative of sine of u is cosine of u plus c, right? And so the idea is if I were to integrate cosine, right, I would get sine, right? Remember, what does this say? Like, this thing is the derivative of what, right? That's really what we're saying. So what is cosine the derivative of? Well, it's the derivative of sine. Okay, so sine of u plus c. Remember, if you take the derivative of c, that's 0. So what is the derivative of sine? Well, it's cosine. So that's why the integral of cosine of u du is equal to sine of u plus c. So same idea. The derivative of sine is the derivative of what? Well, it would be the derivative of negative cosine of u plus c, right? Remember the negative, so you have like -1 times cosine of u plus c. So what's the derivative of cosine? Remember, it's negative sine, so negative times a negative gives you positive sine of u, and then plus 0, right? All right, same thing is true here. What's the derivative of tangent? It's secant squared. So the integral of secant squared of u du is tangent of u plus c. All right, once again, what has a derivative of cosecant squared of u? Well, it would have to be negative cotangent u plus c. So, okay, remember, -1 times the cotangent u plus c. So what is the derivative of cotangent? It's negative cosecant squared of u, right? And then, of course, the negatives reduce, right? All right. So remember, you have to have your derivative rules memorized. So what is the derivative with respect to x of cosine of u? Remember, it would be, well, derivative of cosine is negative sine of u, and then I should have had a du dx here, sorry, not plus c. I apologize, du dx, right? So derivative with respect to x of tangent of u is secant squared of u du dx, right? And we'll talk a little bit more about the du dx, but then you should also have memorized the derivative with respect to x of cotangent of u, remember, would be negative cosecant squared of u du dx, and d dx of secant of u, remember, is secant u tangent u du dx, and d dx of, well, cosecant of u is negative cosecant u cotangent u du dx, right? So remember, these are all of our derivative rules. And so then if we go backwards, integral of cosine, we get sine, integral of sine, we get negative cosine, integral of secant squared, we get tangent, integral of cosecant squared, we get negative cotangent, integral of secant tangent is secant, integral of cosecant cotangent is negative cosecant. Now, remember, all of them have a plus c because if you take the derivative of that, you obviously get 0. All right, now, you notice we have integral of cosine, integral of sine, but I don't have integral of tangent there, integral of cotangent, integral of just cosecant, and integral of just secant, right? You notice these are not in this list. Why? Well, because we don't have a derivative rule memorized where the derivative of something is tangent or cotangent or cosecant or secant. And so we're going to have to learn a little more about integration in order to get those rules. We will be getting those rules, but we have to learn a little bit more in order to do that. So you should be memorizing these 6 rules in addition to the power rule from the first part of the 6.1 notes. Okay, you should have those memorized. All right, so let's apply those rules. All right, so number 4, if I have the integral of 5/6 sine of x dx, right? So what we want to remember is the 5/6 is just a constant. So we write that times the integral of the sine of x dx, right? So that's our rule. The integral of sine is what? Well, we're going to take the 5/6 times the integral of sine. What's the integral of sine? It is negative cosine of x and then plus c. Don't forget about that. All right. And so then we would probably write it as negative 5/6 cosine of x plus c. So just a reminder, if this is the original function, right, what is its derivative? So you obviously have negative 5/6 times the derivative of cosine, which is negative sine of x, right, plus the derivative of c, which would be 0 because c is a constant. So negative times a negative 5/6 sine of x, right, which is our original integrand, right? So that's a quick way that you can check your work. All right, here, if I have the integral of 8 over cosine squared. Now remember, we don't have a quotient rule or anything, so we're going to have to rewrite this. If I have 8 over cosine squared, remember that's kind of like 8 times 1 over cosine squared. But remember, 1 over cosine squared we can rewrite as secant squared of x dx. And so we apply the rule that we just learned 8 times. What is the integral of secant squared? So remember, we're saying what function has a derivative of secant squared. So that's a nice way to remember that it is tangent of x. And then, of course, plus c. So 8 tangent to x plus c. All right, now here we have one thing added to another thing, so we're going to integrate them separately. So the integral of the cube root of x, so x to the 1/3, remember, is the cube root of x, and then dx, and then plus, and then I'm going to have 4 times the integral of secant x tangent x. Anytime we have a constant multiple of a function, we can just bring that in front of the integral. All right, so now integral of x to the 1/3, we're applying the power rule. Remember, we increase the power by 1, so x to the 4/3, right? 1/3 plus 1 is 4/3, divided by 4/3. And then plus, remember, we don't need to add a c in there. We just need to add a c in at the end because it's really only one integral. All right, and then I have 4 times. All right, what is the integral of secant x tangent x? So remember, we don't really have to memorize it because we already have our derivative rules memorized. So we're saying what function has a derivative of secant tangent? It is secant of x. And then, of course, plus c. Now, I might rewrite this as 3/4, and then instead of x to the 4/3, I might write the third root of x to the 4th, and then, of course, plus 4 secant of x, and then plus c. All right, so that is example number 6. All right, moving on to slide number 9. All right, so just a few more practice problems here. If I have the integral of 9 plus 9 cotangent squared, okay, a nice thought for a lot of people is, okay, well then let's split this up. The integral of 9 dx plus the integral of 9 cotangent, not cosine, cotangent squared of x dx, right? Now that looks great, but the fact is that we don't have a rule for cotangent squared, right? Because we don't know something off the top of our head that has a derivative of cotangent squared. So that is actually not the approach we want. What we want to do is we want to rewrite this. I'm going to factor out a 9, and then I have the integral of 1 plus cotangent, not cosine, why did I write that again? Cotangent squared x with respect to x. And we should realize that 1 plus cotangent squared is a Pythagorean identity. So if you don't remember your Pythagorean identities, on the side, you should do a little bit of work. Sine squared x plus cosine squared x equals 1, right? That's the basic Pythagorean identity. And if I want 1 plus cotangent, I need to divide everything by cosine, right? So if I divide by cosine, sorry, not cosine, if I divide by sine squared, I get sine squared, and then sine squared. So remember, sine squared over sine squared is 1, plus cosine squared over sine squared is cotangent squared, and then equals 1 over sine squared is cosecant squared. So 1 plus cotangent squared is equal to cosecant squared. So this is really 9 times the integral of just cosecant squared x dx, and we do have a rule for that. So we remember what function has a derivative of cosecant squared. So it would be negative cotangent of x and then plus c. Remember, the derivative of cotangent is negative cosecant squared, so the negatives would cancel out. And so I would probably write it as negative 9 cotangent x plus c. All right? All right, the next one. Now, this is interesting to think about. All right? Example number 8 and 9. All right? If I have the integral of the derivative with respect to x of 5x squared plus 7x. All right. So what we want to do is we want to realize here that if I look down here, the integral of the derivative of f of x with respect to x is actually just f of x plus c. So this is the integral of the derivative with respect to x of f of x, which is simply f of x plus c. But what is f of x? In this case, it is 5x squared plus 7x. And then, of course, plus c. The one down here, if I have the derivative with respect to x of the integral of x to the fifth plus 6x squared dx, that is actually just equal to x to the fifth plus 6x squared, not plus c. Okay, so now we need to realize why. The derivative with respect to x of 5x squared plus 7x, what would that be? Well, the derivative of 5x squared is 10x plus 7, right? And then if I integrate, then I would get 5x squared plus 7x, and then I would have to add c. But this rule, I would integrate first, so that would become x to the sixth over 6, plus this would become 6x cubed over 3, or 2x cubed, and then I would have a plus c. But then I would have to take the derivative with respect to x of that. And so the derivative of x to the sixth over 6 would be 6 over 6 x to the fifth, so x to the fifth, plus 6x squared, so 6x squared, plus 0. And so we need to remember, or we need to memorize the fact that the integral of the derivative with respect to x of f of x with respect to x is just f of x plus c, and the derivative with respect to x of the integral of f of x with respect to x is just f of x.